ourselves, shall we? So yeah, let's do. It's mental exercise. You don't want to get mentally out of shape, do you? You want to be mentally. You want to be an ultra marathon mentally.
Yeah, but you need to recover.
Recover. You just had a weekend.
No,
Jeez
but right
Louise.
now, let's say we're like running a marathon, like that's our goal. Right now, we can't even walk up a flight of stairs.
So is that going to get better by doing more exercise or less?
Less.
How do you get more shape by doing less exercise?
Do you start having okay, it is scientifically proven that if someone who is dying from starvation, you can't just feed them a ton of the food because then they can't absorb it all and it actually is bad for their bodies. So doing this lesson is killing me because I cannot no, I can't physically.
We're starving from that knowledge.
Starving? Don't do too much. Okay. Okay. I'm going to spoon feed you some math knowledge.
Please,
Real
feed us what we've already covered.
You're going to give a little baby bottle of knowledge, all right?
This is not
This is just days. It's only 3 days. Okay, so let me explain. Now you're looking at the food and saying too much. This is notes over 3 days. You're not going to choke on it.
No.
No, this is 3 days.
We always
It's
choke.
2 papers on 3 days. It's so easy. Okay. All right, if you choke on it, you choke on it. Here we go. Hey, what is a number outside the function do? Think like 2 sine.
See, I didn't know that.
What does that do? So it's think more generally that we don't use amplitude for all curves, just sinusoids. So generally it's a vertical. Okay, so this is a vertical stretch or squish or compression, whatever you want to use. Okay, A will vertically stretch or compress a graph. Right? That's true for sinusoids, but it's true for all graphs. If F stands for the function, okay, so F's not a change. What about if you multiply inside, like sine of 2x? What does that 2 do when it's inside the function with the argument? Horizontal shift or stretch and squish? Okay, so this is horizontal, and it's with the argument. It's a horizontal stretch or squish. I'll use compression because it sounds fancier, but honestly I think squish. And it actually, they both kind of depend on if it's fraction or whole number greater than 1. All right, what about C? What does C do? Start, okay. Think of it in terms of, does it shift it horizontally or vertically? Horizontal, so that's a horizontal shift. Or makes the starting point right or left of where you would normally expect it to be. And D, what about D? Vertical shift. For sinusoids, we think of it as the center line, but it's really just the whole graph. It's not just the center line being shifted, it's the whole graph being shifted, right? All right, what about if you have a negative on the A, a negative outside the function? That's what we talked about Friday. Can we all agree that negatives cause reflection?
Yes.
Okay, when a negative is outside the function, what did it do? Reflect it over the x-axis or over the y-axis? Did you just say y because that's what I said last, or what? Okay. What about y equals negative x squared? What's the graph look like? That's shifted or reflected down. If it's outside the function and the function is y, then you just change the sign of y. So changing the sign of y reflects it across the x-axis. If it changes inside, if b is negative, that's the changing the sign of x, or the argument. If you change the sign of x, like this, what happened here when I put the negative inside the square root? That changed the sign of positive x's to negative, so it made positive x's negative x's. It reflects across the y-axis. Okay. Now then, we'll also say, actually, I'll talk more about this part in a second, okay? You could start to look at things two different ways. So let's go with one or two of these together, and then hopefully you're going to use your calculator to investigate. But the point is this: when you get a base graph of a parabola, what will happen when that change comes? So in this case, that 2, it feels like it's outside the function. So what does that 2 do? Vertical shift or stretch? Vertical stretch. All right. So that's the idea. I just want to do one together. But do the rest either with your calculator, or if you want to just take a guess without your calculator, we'll go over them in about 3 minutes. Feel free to talk them over with your calculator or not. Just the whole, all the ones in the front side. Okay? You might start by doing y equals x squared in F1, so you can compare it to whatever you put in next. You know what I mean? So I would recommend you do the normal in F1 and look at what changes do to the GK. See? Oh, man, you got a pencil? Okay. Another couple seconds and we'll go over those. Okay, so here we go. The first one, y equals -1/3 x squared. That's outside the function, it feels like, and it's got actually two things happening. So what did you say for that one? Anybody? Actually, let me call on people. Eric, what'd you say for the second one? Across x-axis, and then what else? I'm sorry, across the x-axis I agree with, and then vertical. All right, and vertical, if it's a fraction, it compresses, yeah, so squish or compression. Think of it like amplitude. All right, this guy, y equals 2x squared, 2x quantity squared. That 2 is in with the x. So would that be a horizontal or vertical change? Horizontal. And is that a horizontal compression or like shrink or stretch? If I do sine of 2x, what does it take, or what does it do to the sinusoid? Doesn't it make the period shorter? The period of this is pi, yeah? So I ask you again, does 2 stretch it out, or does it horizontally squish, shrink? Shrink. It's a horizontal shrink. And you might have said, gosh, graphically it looked like it went from this to this. So it's possible you said it was a vertical stretch. How could that be? How could it be both? Well, what if I multiplied this out? Isn't this the same as 4 outside the square, x squared? And isn't that a vertical stretch? You could actually look at it as either. You follow me? Okay. John, what did you say for x plus 4 squared, quantity squared?
I said that it moves left 4.
I agree. Left 4. X squared minus 3. Miss Sims, what do you say?
Vertical shift.
Vertical shift. I agree. Is that up or down? Down. Down 3. I agree. Maya, what about this one? X minus 1 squared minus 4. Right, 1 down 4. Cool. This one's a bit of a trickster. What if I said sine of 3x plus 6? What's the first thing you would do? You would factor it. You must factor. This is 3 times x plus 2 squared plus 1. So let's talk about the 2 and the 1. What are the shifts? It's tempting to say it's left 6, but it's not left 6. It's left 2 and up 1. And what does the 3 do? It's inside the function. So is it, when I say the function, I say the big picture is this is a squared function, okay? So if it's inside the function, that's changing x. It's with the x. So is that a horizontal or vertical if it's in with the x? If it's with the x, it's changing x, and therefore it's horizontal. Is that stretch or squish? Horizontal squish or shrink. Which, if I actually squared 9 out, it would look like it was vertically stretched. So that's cool. So factoring this guy. This is negative, parentheses 2, parentheses x minus 2, squared plus 3. Now tell me, what are the shifts? Right 2, up 3. And again, if you said right 4, I understand where you're coming from, but you've got to factor. It's got to be factored. Excuse me. So what about the 2? That's, again, a horizontal squish, which if you multiply it out would be a vertical stretch. What does the negative do? Causes it to open down, opens down. All right. Would you then give a rough sketch of that graph? This graph is for that starred one again. Would you give a rough sketch of that? And I want 2 things. I want you to show me the essential point, which is the vertex. I want you to give me the basic shape, and also find the y-intercept for me. Okay? Okay, I didn't put a y-axis scale on there because I didn't want you to make a table turkey. I want you to tell me the actual shift. So we said it's a parabola shifted right 2 and up 3. Can we all agree with that? Okay, and does this open up or down? Down. And that 2 makes it a normal parabola squished, so it's going to look a little more narrow. And the y-intercept, now we haven't talked about that yet, but no matter what a graph looks like, at the y-axis, the y could be lots of things, but the x you know is 0. At no matter what the graph looks like, no matter where it crosses the y-axis, x is 0 there. So when x is 0 in this equation, what's y? If x is 0, then y is 0 minus 4 squared plus 3. So negative 16 plus 3, or negative 13. So I would have a y-intercept way down here at negative 13. And does that kind of jive with my opening down and narrow kind of thing? Yeah, that feels like that all goes together. You with me? Okay. All right. In the interest of time, let's do these together. Only one more page. Are you choking yet, or are you good? You able to take this food in there? Megan, you good?
No, I'm joking.
Oh, cool. All right. Y equals 3x cubed. So we know the shape of x cubed is this. What's the essential point that we want to focus on? 0, 0. I think I forgot to do that on the last one. The original point on the parabola is also 0, 0. Okay. Now that's the point that's going to be shifted around and stretched out sometimes and all that good stuff. So this 3, it feels like it's not in the cube because there's no parentheses. It's outside the function. If it's outside the function, it changes the y. So is that a vertical or horizontal? Vertical, and a stretch or a squish? Stretch. Amplitude. Okay? Cool. Y equals 1/2 x cubed. That's in with the x, so it changes x. If it changes x, it's horizontal. Is that a horizontal stretch or squish? Stretch. That one's the one that goes opposite of what you might think. It goes half as fast. But wouldn't you agree that if I did actually cube that, isn't that the same as 1/8 x cubed? In which case, then you would consider it a horizontal or a vertical squish. And so horizontal stretch and vertical squish, really, they come out to be the same thing. All right. What about this one? Let's get some participation. Allie, x minus 3 cubed. What does that 3 do? This one. Come on. It's in with the x. So is that going to change it horizontally or vertically? Horizontally. And does it go right or left 3? Right 3. All right. Cool. This one. Ooh. More than me, huh? This one is a bit of a trick question. Who's awesome at this? Spires? Colin? What do you think? Let's go, Colin. Colin, talk to me. What would you do here?
I'd switch the x and the 3 and factor out the negative.
Beautiful. All right. So if you do that, when you say factor out the negative, did you write it this way or just write it this way? First way or the second way? I guess they're the same thing because a negative cubed is still negative. Okay, cool. All right, so what are the two changes that are happening there?
Well, it's reflected across the x, and then it is moved to the left.
Right 3. Now, and this will be the hardest part to this concept, is the order in which you do stuff matters. So when you do changes, they go inside out. So you'd first say this is shifted right 3, then you'd say this is reflected. Is that reflecting, is that changing the sign of x, or is it changing the sign of the function y? the function. And if it changes the sign of the function, it changes the sign of y, then it reflects it across the x-axis. It'll be important that we take a test point to check it. Okay, you with me? X cubed plus 2, what's the change? Ryan, what does that 2 do? Up 2, I agree. Jude, in the next one, what does the 3 and the 2 do there? Try again. This one's with the x, so this is the right or left? Left, it's the opposite. And this one makes sense. So it's which, up or down? All right, now it makes sense. Left, straight down, okay? Then this was the stinker. If you have a coefficient with x, what do you have to do first? You have to factor it, all right? So you're going to take a 2. I'm going to use brackets around the whole thing so I can use parentheses inside. Cube plus 1, all right? Katie, you're living good. What does the 2 do? This 2 do, sorry. Okay, I agree, left 2. Katie Herbeck, what does this 1 do? Okay, up 1. What does that 2 do, China? Multiplying is a stretch. If it's inside the function, does it stretch it vertically or horizontally? Okay, you could, if you took it out, it would actually be vertical. If you left it in, it's horizontal. And either way, the graph effect will be the same. A horizontal squish will look the same as a vertical stretch. They look the same, so that's a bit of a trick question. And then the negative outside causes it to reflect across the x-axis. So, would you please sketch this guy here? Focus on finding the essential point, the middle of the curve. And then focus on the shape. So hopefully you put the bend point or the middle point at left 2 up 1, yeah? And then hopefully instead of this, it is now doing this. And it's even longer like this. What's the y-intercept? When x is 0, y is, what's 0 plus 4 cubed? 64. Negative 64 plus 1 is negative 63. Way down here. So it's a really stretched, cube shape. You're down. Okay. Try these on your own. Let's go 15 seconds each. So let's go 2 minutes. I'll give you 2 minutes. Ask yourself, is it with the x, and therefore changing horizontally, or is it outside the function, and therefore changing vertically? Is it adding or subtracting, and therefore shifting? Or is it multiplying, and therefore squishing? Oh, sorry, I'll get back to a second. Oh, here we go. take practice, but you'll get better and better at it. All right, let's go. Let's see how you did, at least the ones you had time to do. Sense, how do you feel? Great? Really good? Awesome? Who's turn here? It feels like you're saying great. All right, let's see. 2x, that's change inside. So is that a horizontal or vertical change? Horizontal. Squish or whatever. Stretch or squish? Squish. Okay. What does the negative outside do? Reflect across the x-axis or over the y-axis? Across the x-axis, reflect x-axis, and the 1/3 is a horizontal or vertical? Stretch or squish? Stretch. Think of it like the slope of the line is now only going to be 1/3. Okay? What about the negative inside? If it's a negative inside, it's a reflection across the y-axis. What happens though if you reflect this across the y-axis? Doesn't it fall right onto itself? That's like saying that absolute value doesn't do anything. I guess that makes sense because the absolute value of a negative inside is just the same as if that negative isn't there. The sign doesn't even matter. It's going to be the same number either way. The 1/3 horizontal stretch again, yeah? Cool. 6 minus 2x. What did you do very first thing? Factor out of 2. Did you factor out of 2 or negative 2? Negative 2. X minus 3. So, let's go here. What does the 3 do? Choose it right or left? Right 3. What does the 2 do? So horizontal, squish or stretch? Whatever, you know what I mean. Squish, yes. And does the negative do anything? No, because it's inside and the absolute value of a negative is the same either way. It's all good. What about absolute value of x minus 3? What does the 3 do? Down 3. Y equals absolute value of x plus 3 plus 1. Left 3 up 1. And last but not least, this is in order. First you go left 1. Then you go, no, then you go reflect. Then you reflect up or down. I said you work inside out, so you gradually work x on out. So x first, then left 1, then the negative, which is reflection, down, and then you go down 3. So in terms of the order, it would be something like this. Here's the first graph, the absolute value. Then it's left 1. Then it's reflect down. Then it's down 3. That is your graph, and I can verify with my essential point. If I put in a negative 1, don't I get out an absolute value of 0 minus 3 is negative 3? Yeah. So it checks. You can always make a table turkey. All right. Gosh, you don't have time for the whiteboard. Phew. I don't want you to choke on that. All right, digest that and then go back for seconds tonight, huh? For your homework. Oh. Ha ha. Yay! Math for you. Here's some math for you. Bon appetit, all right? Enjoy that. Enjoy that. Dig
Sounds
in.
like yesterday my dog is
This is not safe for dogs. You're welcome. Enjoy that. I will. We'll go over the test tomorrow. It's a little shorter lesson. Hey, then we have to run over again. Have a great day. This isn't going well. Coming 7. Can't stop singing? Have a nice day. Can't stop singing.